Hello everyone. In the last class, we have discussed that Nernst equation for a galvanic cell. So, how do we determine the cell potential or EMF of the cell by using Nernst equation? We have derived it, and also we solve one numerical problem. Today, we'll go with the same remaining numerical problems. So, coming to the second numericals based on electrode potential, standard electrode potential, and cell potential. Right? So, here is the given problem. So, you just first once you read the numerical, before going to solve the numerical problem, first you read the numerical, and next step you want to write the given data by observing this numerical. First you write the given data, and then you just think of which hypothesis or which formula or which equation is suitable by calculating the given term. Right? So, just I will read the numerical. So, here we need to calculate the standard electrode potential E naught of copper 2 plus bar copper. That means, so we need to calculate the standard electrode potential of copper. Okay? Comma. If the potential of copper electrode immersed in 0.015 mole copper 2 plus solution is 0.296 volt at 25 degrees Celsius. First you write the given data. So solution for this. So given data here, we need to calculate the first step. We need to calculate the standard electrode potential. Okay. Then, if the potential of copper electrode immersed in 0.015 mole copper 2 plus solution, see molar, that is concentration of copper 2 plus, they have given. How do we denote the molar concentration? In a square bracket. Molar concentration of copper 2 plus ions, that is equals to 0.015 mole. Right? Then the copper electrode, the potential of copper electrode is 0.296 volt. That is electrode potential we denoted by capital E of copper electrode is equals to 0.296 volt, 0.296 volt at 25 degrees Celsius. So temperature they are given 25 degrees Celsius. So 25 plus 273, that is equals to 298 Kelvin temperature. The standard temperature, we need to calculate the standard electrode potential value. Understanding here? And then next, which hypothesis is suitable? So we already know the equation to find out the electrode potential. So by applying the Nernst equation for single electrode potential here, so only copper electrode is involved. That means that is single electrode. So by applying the Nernst equation for single electrode potential is E is equals to E naught plus 2.303 into RT by NF into log a single electrode potential, that is Mn plus or species, right? So this is the equation by Nernst equation. So by using a Nernst equation, we can write it as E is equals to E naught plus 2.303 RT by NF into log Mn plus. So you first observe which electrode is involved, copper, and the oxidation state number of electrons involved in here is 2. So that means N is equals to 2, right? And we know the gas constant value, that is 8.314 joules per Kelvin per mole, and T temperature they have given 298 Kelvin. Mn plus, that is copper 2 plus ions are involved. That means we know the concentration of metal ions here. And we know the electrode potential value also. They have given E copper. So we need to calculate the standard electrode potential of copper. Right? So I'm rearranging this, or you just first write it. Electrode potential of copper is equals to standard electrode potential of copper plus temperature at 298 Kelvin they have given. So directly you just substitute the value 0.0591 divided by N into log copper 2 plus, right? So here we need to calculate this value, that is standard electrode potential value. So keep this term and bring this whole term into the RHS, right? So here on rearranging copper, standard electrode potential of copper is equals to electrode potential of copper. This term comes to this LHS. That means sign gets changes, minus 0.0591 divided by N. The N value here involving 2 electrons. So here 2 into log copper 2 plus, or you just here write it as N only. Then you substitute the values. So we know the electrode potential of copper 0.296 volt minus 0.0591 divided by N value is 2 log of 0.015 molar concentration. So here you get, while calculating these terms, we will get 0.349 volt, 0.349 volt at 298 Kelvin temperature. This is how to solve the numericals. Here we need to observe which electrode is involved. So copper electrode, that means the oxidation state of copper is +2. Understand here? Yes. Next we will discuss we'll go with the third numerical. Okay. Yes. Here. Next numerical is iron rod immersed in iron rod immersed in ferrous sulfate iron rod immersed in ferrous sulfate solution means FeSO4 solution of 0.25 mole and copper rod immersed in copper sulfate solution means CuSO4 solution, copper sulfate solution of 0.45 mole. Full stop. Standard potentials of copper and iron electrodes are 0.34 and minus 0.41 volt respectively. Give cell representation. Cell reaction and calculate EMF of cell at 30 degrees Celsius. Yes, this numerical is different from the previous one. So in the previous two numericals we have discussed, we have determined that electrode potential, right? So here we need to calculate the cell potential, right? So cell is nothing but a coupling of two or more electrodes. Here coupling of iron and copper electrodes. So once again I will read the numerical. Listen carefully. Iron rod immersed in FeSO4 ferrous sulfate solution of 0.25 mole and copper rod immersed in copper sulfate solution of 0.45 mole. Standard potentials of copper and iron electrodes are 0.34 and minus 0.41 volt respectively. So give cell representation, cell reaction, and to calculate the EMF of the cell at 30 degrees Celsius. First you need to write the given data. Yes. Iron rod immersed in FeSO4 solution, that means molar concentration of Fe2 plus ions given, that is molar concentration of FeSO4, or you can write Fe2 plus ionic concentration is 0.25 mole. And copper rod immersed in copper sulfate, that means copper 2 plus ionic solution. So molar concentration of Cu2 plus ionic concentration is 0.45 mole. Standard potentials of copper and iron electrodes are, that is, standard electrode potential denoted by E naught of copper. E naught of copper is equals to 0.34 volt. 0.34 volt. The unit of potential is volt. Unit of concentration. So generally molar concentration we are taking. And then standard electrode potential of iron is given minus 0.41 volt. Standard electrode potential of iron is minus 0.41 volt. Yes. So here we need to calculate the cell representation, cell reactions. So and then calculate the EMF of the cell. At temperature they are given T is equal to 30 degrees Celsius, that is 30 plus 273, that means so 303 Kelvin. 303 Kelvin. Right. So and then we need to write the cell representation. Cell representation and cell reaction. Cell reactions. And then at last E cell we need to calculate. For EMF of the cell we need to calculate at 30 degrees Celsius. Right. So now coming to the hypothesis. Yes. So this numerical is based on the Nernst equation. By using Nernst equation, we derived that galvanic cell equation. Okay. So apply Nernst equation for galvanic cell. That is, E cell is equals to E naught cell. E cell is equals to E naught cell plus 2.303 into RT divided by NF into log molar concentration of metal ions Mn plus at cathode divided by molar concentration of at anode. Okay, this is the equation is applied for this solving by calculating the EMF of the cell. So before that we need to write a cell representation. Right? Yes. Yes, here only. Cell representation. We know that how to notate or how to represent the cell. So first thing is, while writing the cell notation or representation, so first we need to write the anode electrolyte, that forms a oxidation of cell, double slash cathode electrolyte and then cathode. So here which is anode and which is cathode. How do we identify? So observe the electrode potential here, which is having a less electrode potential, that is undergoes easily oxidation. That is iron electrode here in the given cell, iron electrode acts as anode. That is, so first we need to write the anode. So that is iron. Single slash. This represents the interface between the electrode and the electrolyte. So here electrolyte is ferrous sulfate, FeSO4 or Fe2 plus aqueous. Fe2 plus aqueous. And concentration we have given, we need to write in the bracket. So concentration of Fe2 plus is 0.25 mole. 0.25 mole. Double slash, then copper 2 plus, Cu2 plus aqueous. So concentration is given 0.45 mole, and then copper electrode. So this is how represent the cell. So first we need to write the anode electrolyte with the concentration. We have to mention here, and double slash, this represents the salt bridge, then cathode electrolyte, and then at last the cathode, single slash cathode. Right. Then cell reactions or net cell reactions or cell reactions. Cell reactions. How do we write the cell reaction? So first at anode, first write the electrode reactions. At anode, what happens? As we know that anode undergoes oxidation. That is, here anode is iron, a metallic iron, undergoes oxidation gives rise to Fe2 plus ions at aqueous solution plus 2 electrons, right? And at cathode, this is off-cell reaction or off-cell oxidation reaction. And at cathode, what happened? So here the copper 2 plus aqueous, which gain the electron, that is 2 mole of electrons, and which undergoes reduction, that is which produces formation of copper metal. Yes, this is reduction half cell reaction, half cell or electrode reaction we can say. Okay. So now we need to write the cell reaction or net cell reaction, or we can say overall reaction. So how do we write the overall reaction? So here electrons gets cancelled. So the remaining term in the first anodic compartment. So here is Fe, right, plus copper 2 plus aqueous, gives rise to, it is redox reaction, it is. So reversible reaction. And then right side, the remaining terms in the right side. So some of the remaining terms here, Fe2 plus aqueous, Fe2 plus aqueous plus copper. So this is the cell reaction. This cell representation carry 1 mark. Just representation, notation of the cell. You have to remember how to identify the anode and cathode. As I am telling again and again, anode which undergoes oxidation. That means which is having a less electrode potential value, standard electrode potential value. So that acts as an anode and the remaining one acts as an cathode. Okay. So this is cell representation and cell reaction. This cell reaction carry 2 marks and then 2 plus 1, 3. The remaining 2 marks is for solving by substituting the values for this and determining the E cell or potential, cell potential or cell voltage. Okay. So I will write in this side. Yes. So by using this, we need to calculate E cell is equals to E naught cell plus 2.303 into RT, R that is gas constant 8.314 joules per Kelvin per mole, T temperature 303 Kelvin divided by N number of electrons involved. Here is 2 electrons are involved for this reaction. So here 2 into F, Faraday's constant. We know the Faraday's constant value is 96,500 coulombs. That is 96,500 coulombs. And log of metal ions at cathode. Metal ions at cathode. See here, molar concentration of cathode. So which is cathode here? Copper electrode. Copper 2 plus, we can write copper 2 plus divided by Fe2 plus. Right? And here we need to calculate the standard electrode potential, okay, of the cell. So how to calculate standard electrode potential of the cell? So we know the formula E naught cell is equals to E naught cathode minus E naught anode. So here which is cathode? E naught copper minus E naught iron in the given numerical. Okay, so we know the value E naught copper is 0.34 volt minus, so minus of minus 0.41 volt. So we will get 0.75 volt. 0.75 volt. So E naught cell value is 0.75 volt. So substitute in this equation. So here 0.75 volt plus 2.303 into 8.314 into 303 divided by 2 into 96,500 log of. So copper concentration is 0.45 divided by 0.25 divided by 0.25. So when you calculate this in a scientific calculator, you will get, so please use the scientific calculator. So in a single line you have to calculate the numerical to save the time in examination. 0.758 you will get 0.758 volt. we need to represent the voltage in terms of volt. So that is the cell potential is 0.758 volt. So this this E cell, by calculating this E cell carries 2 marks and cell representation carry 1 marks and cell reactions carry 2 marks. So here this is how to calculate the numericals, to solve the numericals based on E cell. Okay. So one more numerical is left. So I will continue by next class. Right. Okay. Thank you. Thank you everyone.